In this video, we're going to show how to generate contour lines on a series of tin surfaces, or actually triangulated irregular network. So you can see we've got a map here of contour points where the contour points are represented as circles, and the point number is the first number at the top, and then the elevation's given in the bottom number here. And I've got a tabular set of data that defines all these coordinates, both the northern, the eastern, and the elevation, or N, E, and Z. But just for reference, point 11 here is located at 100, 100 in terms of northing and easting. And then all of these points are on a grid of 20 feet. And then on the printout here, you can see there's actually a smaller grid that is on units of 1 foot. So when we go to locate these points, we can get within about a half a foot by going in between these grids as well. But what I would like to do is generate contour lines for contours which are elevations. It's a line of a constant elevation. So for instance, if we wanted to generate a contour for the 97-foot elevation, you can see between point 11 and 12 we go from 96.8 to 98. So there's a 97-foot contour in here, as well as between point 11 and 7, and then point 11 and 6. So what we're going to end up doing is just drawing points on these edges that represent the elevation of integer values from 97 all the way up to 102. And in order to do this, we're going to use interpolation along this edge for both the northing and the easting heading. So if we take a look here at just general interpolation, if I've got a figure that I still have yet to put in here, if I've got a figure and this figure shows an independent axis S and a dependent axis F. And what I want to do is I've already got 2 points, S1, F1, and S2, F2, and I want to know what the F value is at a particular S. We'll call it S star. So we're going to use these 2 points to do linear interpolation at the value of S, called S star, to get me the value of F star. Now the reason you'd want to do this is if you knew Z's and the ends of these 2 points, you could find the northing that corresponds to a given elevation. So we can look at the formulas here for interpolation such that my new F value is equal to F at point 1 plus the delta F over the delta S times my new S minus my S1. And what this gives you is the point F star that corresponds to S star based on linear interpolation. So our dependent variables for these problems are our Z's, or our elevations. We know what elevation we want, and we want to return the northing or the easting. So the F values in this would either take on an N value, which is your northing, or your E, which is your easting. And the S's, which is the dependent variable, is your Z's. So in this particular case, if we wanted to, we could plug in a Z star of 97 and use 2 points on our triangular surface to generate the rest of these values here to come up with the northing. Same with the easting. So what we're going to do is generate a spreadsheet. We've got data on Isidore already under the resource folder. It's under tin project, and it's this tin problem. So I'm going to save this. I'll just save it to my desktop for now. We can show the location in the folder, and then I've got my Excel workbook open. I'm going to do a file open, and I actually want to open it from the computer. And if I go to the desktop, I can find that file. Now what you're going to have to do is actually change the file type, because what we would want is a text file, and that's not a default option, but Excel can handle it. So I'll find my text file here, which is this tinproblem.txt. And it brings up the import wizard. Now this is a delimited file. It's delimited based on commas. So if I pick comma and hit finish, it separates all the data into individual columns. I'm going to left click on column or row 1, right click, go to insert, and I'm just going to label these as P, N, E, and Z. So this is the point number, the northing, the easting, and the elevation. Now we could do a calculation max Z and min Z on this data, and that's just using the max formula over this range of cells and the min formula over that same range of cells. Alright, so we know we have to go from intervals of 97 to 102 because those are the whole numbers between this range of the min to the max. So what we want to do down here is build a little table to implement our interpolation function. So we want to be able to interpolate for an n and an e between 2 points. So what we're going to do is we'll call this point 1 and point 2. And this will be the ID. And we'll return n, e, and z based off of a VLOOKUP. So for instance, let's start with the very first one. So if we want to go to 97, we can find that between point 11 and point 12. So we'll put 11 here and 12 here, and we're going to use a VLOOKUP formula to find the values of n, e, and z. So we'll use VLOOKUP, and we're going to be looking up the 11, and I'm going to lock the b because that doesn't change. We're looking in this table here, and I'm going to lock all that using F4, and n shows up in column 2, and I want an exact match, so we'll do false. I can copy this over, and since I locked my b, that stays put, I locked my table, that stays put. So for the e, I'd be looking in column 3, and the z, I'd be looking in column 4 of my table. So we can verify that these are correct by looking at the data here, and those all match up. So I should be able to copy this down, and 12 should be accurate as well. So now we have the ability to return these points automatically by updating these two cells. We'll give them a little color. And now what we can do is implement our interpolation function. So we'll have a cell, we're going to do some calculations here. So you'll notice, we need to find the delta between these points. So n2 minus n1 and z2 minus z1. So let's find the delta between these, which is just going to be n2 minus n1, and I can copy this. And so this is e2 minus e1, and this is z2 minus z1. So these will be helpful for simplifying our formula. So if you have a new z, we'll put these in order. Here's the new n and the new e. Right, so this is where you actually enter the value you want, and in our case we want 97. So our formula for our new n, or n star over here, would be equal to the original n plus our delta n divided by our delta z times the z we want minus z1. And I'm going to go ahead and lock the z's. The delta z is going to stay fixed, and I think the rest of this will transfer over. So when we copy this over, we'll just check it, and that's obviously wrong, so I forgot to lock that one. And now you can see that this makes sense. Alright, this is a contour of 97 feet, and it's far closer to point 1 than it is point 2. So it's going to be a lot closer to 100, 100 than it is to 100, 120. And so we've got our answer down here. And if we go to our map now, we would put a point at 100, which is in the n direction, and 102, which would be 1, 2, and about 2.5. The actual value was actually close to 103. So we'd come over here to 101, 102, 103, and put a point here. Now the next thing we'd have to do is actually connect that to a dot somewhere between 11 and 7, so we can do that next. So I'll just show this in PowerPoint here as a way to add these things. Alright, Alright, so I'm just going to put a dot on here, and we'll come back in a minute and add a line. So we want to go from 103, and we'll figure out where we need to go from 11 to 7. So all we have to do is come back to our spreadsheet and change this next point to 7. And now we know we need to go to 101.1 and 101.1. So we'll come back here, and you could just mark this on your paper with a pencil, but we want to go to 101, 101, which if we zoom in a little bit further, this is 101. So we want to go to just about there. And then the last one would be between 11 and 6. It goes from 96.8 to 99. So we'll go from 11 to 6. And we need to go to 101.3 and 100. So 101.3 and 100. So the first number is up, down. And what we could do at this point is actually draw our contour. So we want to go from this point from that point to that point to that point. Alright, and I'll change this color to red just so you can see it. So once we make this red, I'll get rid of these other points. And now we can move on to the next one. So I'll go to contour 98. So we'll change this to 98. And we actually do know we need to add that between 11 and 6, so we'll start there. So 108.8. And I'm just going to copy these so we don't have to keep adding dots to our chart. We need to go from 11 to 7. So I'm pasting as values. And then 11 to 12 as well. Alright, so now we just need to connect the dots. So we need to go from 108, so 1, 2, 3, 4, 5, 6, 7, 8, 108.8, so about here, to 107, so if this is 8, these are at a 45-degree angle, so that means that's 8, that's 7, so this is going to go to about here, and then this goes almost all the way to the end point here, so 119. And we'll change that color again. Alright, so there's my 98-foot interval. Now the next one's going to be 99, and this one will require a little bit more interpolation, but you can see we still have to go from 6 to 11, and then the next path would be again from 11 to 7, and then it would be from 7 to 12, somewhere between here. And then, where does it go from here? It's 99, right? So now we need to go between here and here, and so on. So you just have to find the edges that span the contour that you're looking for. So I'll leave this to you. So you've got 99, 100, 101, and 102 to complete. And we can use our spreadsheet. And if you just do copy paste here, we can keep track of all these things and make pretty quick work of it. So let me know if you have any questions.